So hello everyone. This is Akalpit and that's my teammate Rakeen, and this is our project LLM Embedding XR Visualization. On to Rakeen now.
Hey everyone. So for our final project, we made a package for visualizing large language embedding spaces from Hugging Face models with just the model name as input. We were inspired by the belief that data should be experienced and not just viewed. We're bridging the gap between 2D plots and spatial understanding in the LLM embedding space. The fundamental limitations of 2D screens is trying to compress 3 dimensions into two, and it has always either sacrificed information or clarity. Our platform breaks free from these constraints, transforming raw data sets into immersive XR visualizations using nothing but the name of the model from Hugging Face. Every visualization is accessible on your Meta Quest XR headsets. We're not just plotting data, we're creating a new way to discover insights through spatial exploration, one that respects the true dimensionality of our data. So for our project, we do have a library, as we mentioned. To install it, you just have to run this command. To make sure that it runs on a wide variety of computers, we actually did a demonstration in Google Colab. You can simply install the library like this, importing other necessary packages and installing the Xformers library, which is necessary. So LLM Embedding Viz help will give you all the options that our command line tool takes. Of course, I forgot to mention that our Python package is a command line tool. You can pass it a model name. You can pass it a reduction algorithm. You can choose from UMAP, PCA, TSNE, ISOMAP, and MDS. We will provide a brief introduction to this in our README. Uh, the words that or sentences that you want to see in the 3D visualization. Also for the coloring purposes, you can also pass us the domains. But if you don't want to do that, you can also give us a CSV, or you can choose to ignore all three of these, and we just have a default set of words that get visualized if you don't pass any of these. You can also set where it will be outputted, and the S flag just plots a 2D visualization of the 3D object that you can then export into your MetaQuest. Here's an example. We're running the default version, just setting the output path, and the S flag gives us the 2D plot. We can see this is what you should see when you run our CLI. Just gonna run through step by step. I am gonna run one of these just to show that it is actually running. So the DAE file that gets generated, you can go to image2stl.com and then just load it, and you can see it. If you're using SketchUp, the app that we recommend, you can actually then upload this to the cloud and visualize it from a MetaQuest headset, as you can see in this GIFs. Here's another example, but with a different model and a reduction algorithm specified. We're using PCA here. Yet another model that we're running, this time with the UMAP. And this is what we expect our CSV inputs to look like. So I just included an example of what that would look like. It needs words and domains columns. And here's an example of how the CSV input works, the /C. So let's run one of these. Let's run a smaller one so that we know how it works. And then there you go. The model gets saved here. You can download this model. There you go, it got downloaded. Then you can actually go to this website, image2stl.com, and load that model and actually be able to view it just to know that your 3D object is indeed generated properly. And you could then go through the entire process and see it on your MetaQuest. Now, Akalpit will go over our dashboard.
So for the purpose of making life easier, we decided to make a dashboard for the people who don't want to go that much into like the hard coding bit. So over here we have a Streamlit dashboard in which you can just enter whatever Hugging Face model, which supports an automodel and tokenizer. You can set out your output file path. You can save it however you like, and then you can choose what kind of input type do you want over here. You can choose words, sentences, or CSV over here. You can just put sentences and tell what domains or they are. You can put domains and then put like 10 words or 12 words in each other. Then you can select the dimensional reduction algorithm which you want, TSNA, UMAP, ISOMAP, MDS. And after that, you can just hit the generate embeddings button and it will generate the DAE file and it'll go to your output path. And you can just use that DAE file in your 3D viewer. You can verify it again through the website that free website that we showed you. And you can then use that DA file and go through your data in VR. You can walk through your data and visualize it in a much better understanding. And I think that's more or less it from our project. Thank you everyone for watching.